The key to solving these three problems is the idea that the uh, total kinetic energy always remains the same as long as there are only conservative forces acting on the object from within the system. Most notably, as long as there's no friction. So for part A, what's the total mechanical energy? Um, that total mechanical energy is the product of kinetic energy plus gravitational potential plus elastic potential energy. Now in this case, it's just the book that's falling, so there's no spring anyplace. So this number goes away, and we can just say that it's kinetic energy plus gravitational potential energy. But I always like to start with all three types of energy so you're prepared for any type of situation. So the kinetic energy is 1/2 mv squared, and the gravitational potential energy is mgh. M is 1.8 kilograms. Um, V is 4.8 meters per second. That speed occurs when the height is 2.9. G is obviously 9.8, as M is 1.8. So this becomes 32.26 joules is the kinetic energy plus 51.16 joules as the gravitational potential energy, which totals 83.42 joules for the total energy. And that means the entire trip down for the book from the top of the football stadium to the ground, the total mechanical energy is the same. So we calculated at one particular point. Part B asks for the total mechanical energy the instant it was released. Well, it's the same exact thing as the point that we calculated it at, 83.42 joules. Which means at the very top of the football stadium, because the object is dropped, there is no kinetic energy at the top of the football stadium. So when we go to do the total energy equals Ke plus gravitational plus elastic potential energy, because again, we want to always have that particular setup. We can evaluate from there. Well, there is no kinetic energy because it's dropped. There's no spring energy because there's no spring really anywhere. So the only type of energy is gravitational potential energy. So the total energy is equal to m times g times h. So if I take this total energy and divide it by m times g, it equals h. So that's 83.42 joules divided by 1.8 kilograms times 9.8 meters per second squared gives me a height of approximately 4.73 meters. And that sounds realistic to me. A child in a swing is traveling 4.2 meters per second. That means you know there's speed, which means you know there's kinetic energy, and has 315 total joules of total mechanical energy. What's the gravitational potential energy? So again, we know the total energy mechanically is made up of kinetic plus gravitational potential plus elastic potential. But again, in this case, it's a person on a swing. There's no spring associated with this. I like to start with that, but oftentimes it'll cancel. But then you're going to come up with situations where something else might cancel as well. What's the gravitational potential energy? Now I've got E total is equal to this plus this. So then E total minus the kinetic energy is going to equal the gravitational potential energy. So the total energy is 315 joules minus 1/2 mv squared is going to equal the gravitational potential energy. M is 28 kilograms. V is 4.2 meters per second. Make sure you square it. And if you do that, the kinetic energy comes out to be 247 joules, roughly. 247 joules. Which means that the gravitational potential energy has a value of roughly 68 joules. How high is that above the ground? Well, again, we know that PE sub G is equal to M times G times H, same algebra as we had up here. potential energy due to gravity divided by m times g equals h. 28 and 9.8, that gives us a height of roughly 25 centimeters, which means it's pretty low to the ground. The last question is similar. Ball moving straight upwards with 17 joules of kinetic energy and a total mechanical energy of 25. Again, the total energy is Ke plus gravitational potential energy. Again, plus elastic potential energy, but in this particular case, again, there is no elastic potential energy. So therefore, the total energy minus the kinetic energy is equal to the gravitational potential energy. So 25 minus 17 gives us 8 joules for the first question. Well, that 8 joules, gravitational potential energy equals mgh, which means, again, the potential energy due to gravity divided by m times g is equal to h. So 25 divided by 3.2 times 9.8 gives us a height of about 0.26 meters. Well, what's the speed of the ball? Well, that comes from the 17 joules of kinetic energy. So kinetic energy equals 1/2 mv squared. Therefore, twice the kinetic energy divided by m square rooted is equal to v. 2 times 17 divided by 3.2 square rooted gives us 3.26 meters per second. Now, if you got 10, you just forgot to take the square root. Just be careful of that. What's its gravitational potential energy when it's highest point above the ground? Well, when something is traveling up in the air and then turns back around, it comes back down. At this highest point, the velocity is 0. Therefore, the kinetic energy is 0, which means all of the energy is in the form of gravitational potential energy. So if there's 25 joules of mechanical energy all the time, and at any given point there's no kinetic energy, and of course there's no spring energy, then the maximum gravitational potential energy is when all the mechanical energy is equal to gravitational, or 25 joules. So what height is that at? Well, that's the same setup as part B, just with a different number of gravitational potential energy. Up here, we used 8 as the gravitational potential energy. Down here, again, we're going PE sub G equals mgh, but we're trying to solve for h. So h is gravitational potential energy divided by m times g. Same thing as up here, except now we've got 25 divided by 3.2 times 9.8. So instead of 8, we've got 25, so it's roughly 3 times higher. So we got roughly 3 times more height, and if you plug those numbers in, you get 0.8 meters as your height. And then F is the same thing as C. K equals 1/2 mv squared. Solve for V, and we get twice the kinetic energy divided by m square rooted. But of course, what's the speed just before it hits the ground? Well, just before it hits the ground, all of the energy is in the form of kinetic energy. So there's going to be 25 joules of kinetic energy divided by 3.2 kilograms gives us a velocity of roughly 3.95 meters per second.